All right, so we're just going to continue with section 1-4, the stuff that we didn't finish yesterday. So let's do this first. So we talked about an angle, right? An angle's made up of two what? What was the word? Two rays. Very good. Okay, and the two rays, the two rays have a common what? Yeah, it's common. Yeah, they have a vertex, but we don't call it's the vertex of the angle, but of the ray we don't call it the vertex. Say it. Is the endpoint, right? They have a common endpoint, and that common endpoint is called the vertex. Okay, so when we're talking about the rays themselves, it has an endpoint, and these two rays have a common endpoint, which makes an angle, and that common endpoint is the vertex. All right, that's review. Everybody with me on that? So let's do this. Let's stick a point somewhere in here. Well, let's make it green this time. Let's put a point right there. Okay, now, if I said I put a point right there, would you say that that point is inside the angle or outside the angle? Yeah, inside, okay? The last class, the 5th period class I taught yesterday, I don't know if they were just messing around with me or what, but a lot of people said, oh, that's on the outside of the angle. But, I mean, it's in between those two rays, isn't it? So I would say that's inside the angle, or we have a better word for that. We call it, it's in the interior. Okay, that's an interior point. It's in the interior of that angle. All right, so this isn't much of a stretch. So this point right here, if this is interior, this point out here would be what? Exterior. Good. It's just vocabulary, isn't it? Exterior. Yep. That comes into play in something we're going to talk about a little bit later, but I just thought I'd throw that out to you so you know what's interior and what's exterior. So really, any point. Right? Any point in this shaded area right here, and if it kept on going, would be the interior. Any point outside the angle would be the exterior. Make sense? Good. All right. That was pretty easy. We did talk about, I think I skipped this in the other class. I just want to make sure I did it in here. I think I'm almost positive we did it in this class yesterday. We did this, right? Okay. And then, remember how you name an angle? I'll call that A, B, we'll call this one C, we'll call this D. All right. So if I wanted to name, let's say, this angle from here to here. All right. See what I did? I put an arc right there, and that's what we call it. We're going to use those arcs a lot all throughout the year. Okay. This is an arc, and it's just showing you which angle I'm talking about. Sometimes we'll put a number here. Sometimes we'll put like a 1 right there. All right. You could show another arc. Now watch. I wouldn't put if these angles are not equal to each other. If I put one arc here, I wouldn't put one arc here. What do you think? If I put one arc for each of them, what do you think that might say about the two angles? That they're equal to each other. Very good. Do you see that? If I put one arc here and one arc here, that would tell them, or that would tell whoever's looking at this, that those two angles would be equal to each other. All right? Well, these two angles are not equal to each other. So I'm not going to put one arc and one arc. I'm going to put two arcs. Do you see that? So all this says is this angle right here is not equal to this. And how do you know that? Well, this has two arcs and this has one arc. It's like the tick marks. Remember doing the tick marks? If two sides have one tick mark, then the two sides are equal. If one side has one tick mark and the other side has two tick marks, then what? They're not equal. It's kind of the same thing with angles. Now, some books, this book doesn't do it, but some books do this. They'll, oopsie daisy. Where did all that come from? Delete that. Let's do this. I hit Control Z to undo something. I must have hit it a couple times, and the last thing that I had put on there popped up, I guess. Some books do this. Now, don't write this down, okay? But I just want to see, just because in case you, I don't know, you go to college, you see a book and they do it like this or whatever. Some books might do this. They'll put like a one tick mark on the arc and another tick mark on the arc. So any arc with one tick mark are equal to each other, and then like if I did this, that means these two angles are not equal to each other. Does that make sense? We're not going to do that in here. We're just going to use the angle or that little arc thing. All right, so there we go. Now, what would another name for angle 1 be? If I was going to name it angle 1, could I name it just angle B? All right, I could say ABC, angle ABC, couldn't I? All right. Could I just name it angle B? I really couldn't name any of the angles angle B, even the biggest angle right there. because I'm not sure what angle I'm talking about. Because look, angle 1 has a vertex of B, doesn't it? Angle 2 has a vertex of B. And the whole entire big angle has a vertex at B. So I just can't call it angle B because there's more than one angle coming out of that vertex. Everybody see that? So if I have more than one angle coming out of that one vertex right there, I just can't call it by one letter. I have to use 3 letters, or if they put numbers in here, I can use those numbers. All right, so Zeke said angle 1 is angle ABC. What about angle 2? What could I call angle 2? CBD. Now I could go the other way as well, couldn't I? I could go DBC. It doesn't really matter. As long as what? The middle is which one? Right, the B, or the, in general, the vertex. The vertex, okay? So as long as the vertex is in the middle, in this case it's B, that's the vertex, that's how we name it. Can you say this is angle CDB? No, because D is not the vertex, is it? All right, that is not this angle that we're talking about right here. Everybody got that straight? Again, it's very important. You may look at it and say, this is really not that big of a deal. Well, it kind of is, because we're going to be using this stuff just, day after day after day after day. All right, so it's really, really important that you know how to name these angles, because they're going to either ask you to name an angle or they're going to give you an angle, and you have to know which one they're talking about. And that's very important. All right, we good with that? Any questions on that? We good? All right, let's move on. So that was all old stuff. Let's do some new stuff. We talked about measuring in degrees, right? Talked about right angles, obtuse, and all that. Okay, let's do a little example with that stuff. This is right from the book. It's on page 38 if you want to look, but I'm just going to write it out, because this is kind of stuff you'll see on the worksheet. And then it looks like this. Looks like that. Okay, I'm not going to draw the arrows on here, but just pretend there's arrows on all these and they're rays and all that kind of thing. All right, so let's label it. Are you writing this down? Write it down. If I'm writing it down, you should be writing it down. Don't make me do all the work. This is N. I still see people not writing. This is M, and this is L. All right. It says classify each angle as right, acute, obtuse. But then it says use a protractor. I'm not going to make you use a protractor on this, but we'll just figure out which ones are right, which ones are acute, and all that kind of thing. Put a little box right there. Everybody see that box?
Is that the same thing as?
You have 2 of them there? Well, it does. It only has to be on one side, but I'll show you. Here's what Cookie was saying. If this is 90 degrees right here, which angle is 90 degrees according to this box? Let's name it. MJP. MJP, right, so that's 90 degrees. Now, knowing something about a straight line is 180 degrees, isn't it? So look at this angle right here. This angle is 90 degrees. Tell me something about angle MJK. That's going to be 90 degrees as well. Everybody see that? I only put a box. In fact, I'll do this in a different color just so it stands out a little bit more. Look at this pinkish. Right there. So the book told you that this was a 90-degree angle, but you should be able to figure out now that MJK is also a 90-degree angle, right? So if I said name the right angles, name all the right angles, what would they be? It would be angle what? Let's name them. MJ, ooh, what's that? Update? Nah, forget that for right now. I'm teaching. All right, so it's MJP, right? That's the first one. That's the one that they told you was a right angle. But then from there, we could figure out the other right angle. What's the other right angle? MJK. So angle MJK. So that would be your right angles, wouldn't it? Okay. Everybody see that? Now, you could put a little box here if you wanted to, but you don't really need to. Because you should know already that that's a right angle. But you can do it if you want, just to kind of remind yourself. What about a straight angle? Let's name a straight angle. Can you go MJ for a straight angle? You need 3 points. Now, that is a straight line, you're right. But we don't know. KJP. I heard you, Cookie. I was just trying to get somebody else to say it. Okay, so KJP. All right, so that would be a straight angle. How many degrees is a straight angle? 180 degrees, and a straight angle makes a what kind of line? Well, we'll get to that in the next lesson. Obtuse. A straight angle makes a obtuse angle. What is that? What's that mean? Okay, I don't know. I don't even know what you said. I know it probably wasn't nice, so I'm not going to say it. All right, so what is it? Angle what? K, J, P. It's a straight angle. It's 180 degrees. It's a straight line, right? It's a straight line. It's not obtuse. It's a straight angle. Equals 180 degrees. What's a right angle equal to? How many degrees is a right angle? 90 degrees. Okay. Let's name an acute angle. All right. So let's see. MJP. Is that what you said? Or you said N. Oh, okay. I thought you said M. Right. So NJP. Yeah, that looks acute, doesn't it? Because it's less than 90. Obviously, because look, if this whole thing is 90, this is closer to the 0, isn't it? Remember that protractor yesterday? So yeah, that definitely looks acute. So let's name it. Angle NJP. Now, if you wanted to, you could call it what else? PJN. All right? It's up to you. But I'll just go this way. I think that looks a little bit nicer. Are there any other acute angles? Yeah, what about this little one right here? Yeah, that one right there. That looks acute, doesn't it? So let's name, I'll tell you what, let's go in order. Let's kind of go around the horn here, right? So we did this one, didn't we? We'll just call it angle 1. Is that all right? And then you got another one, don't you? I'll tell you what, I'm not even going to name those. Then you got this angle right here. So let's name that one. That looks acute. That looks less than 90 degrees. So it's what? Angle MJN. Good. All right. Acute means less than 90 degrees, okay? Or between 0 and 90, but less than 90 degrees. That's definitely less than 90 degrees, isn't it? All right. Is there another acute angle? Looks like that one, right? LJM. Good. So put the angle symbol in front of it, LJM. Sometimes my L's kind of look like my angle symbol, so you got to be careful with that. Is there any others? Probably this one right here. Do you see that one? That looks acute, doesn't it? Yeah, that looks less than 90. LJK. Good. Angle L. You could say K so the L doesn't look like the angle. Okay, you can do that. Alright. It doesn't matter though, does it? You could go KJL, right? KJL. And Cookie said do it like this just so that the angle isn't right next to the L so it doesn't look that confusing. So, yeah, that's good enough right there. I don't know. Maybe this one right here. That's a possibility, right? That could be acute. I'm not really sure though. I mean, that's so close. It looks really, really close to what kind of an angle? Looks close to a right angle, doesn't it? But it might be slanted just a little bit. So that looks like it could possibly be an acute angle, right? Now, I don't think they're going to say name all the acute angles. They may say name one acute angle or maybe name 2 acute angles. All right, so do the ones that are obvious. The ones that aren't so obvious, look at this one. This one from here to here, it looks like it could be acute, but it's not real obvious, okay? So I probably wouldn't name that one. All right, what else do we have? Obtuse, right? Do you see any obtuse angles? KJN. Yeah, that looks obtuse. Look at this. This one right here. Do you see that angle? Because look, if I go KJM, that's 90, but then I got to take this, see, and it went further away from 90. It went bigger than 90, didn't it? Do you see that angle right there that I've marked with that little arc? KJN. That looks obtuse. Oops, let's put the angle. Okay, let me write this down first. KJ what? N. Looks like alphabet soup after a while, doesn't it? You guys even eat alphabet soup anymore?
No.
Used to. I don't know. I was wondering. When I was a kid, we used to eat it all the time, but do they make it? All right, so what's another one? LJP. Yeah, that's a good one. Tell you what, let's get rid of this arc. I'll just draw an arc for each one of these. So LJP. Yeah, that's definitely obtuse. Or you could go PJL if you don't want the L next to the angle, right? PJL. Are there any other, what is it? NJK? Yeah, that's right here. I think that might be all the acutes, or the obtuse, sorry. You see any other obtuse, man? No? You have a question? Just stretching. Okay. Yeah, that looks like all the obtuse angles, all right? So that's the kind of stuff they're going to ask you. They're going to give a picture like this. They're going to say name a right angle. They may not tell you to name all of them. They'll just say name a right angle, or name a straight angle, or name an acute angle, or name an obtuse angle. Yeah, on a quiz and a test, they could do the same thing. All right, so that's not too hard, is it? Just make sure that look at every single one of these. Every single one of these. What was in the middle? J. J was in the middle because the J was the vertex to every single angle coming out of here, isn't it? All right, so make sure that you write it like that. We good with that? All right, hopefully this is sinking in. You know what I did last night? I must have been really bored. I sat and I watched one of my own YouTube videos. So every once in a while I'll do that. Not every night, but maybe once a week, maybe once every couple weeks. I'll sit and watch it just because I want to hear what I say, and maybe I said some things that were wrong, or maybe I said some things that I want to repeat again that were good, you know. So I was actually listening, and you know what? Even though I was the one that was teaching, I still heard stuff that I kind of forgot that I said, and that was the very day that I taught it, you know. So if the person that actually teaches it can get information hearing it the second time, and I'm the one that said all the stuff, right? If I can get stuff out of it, I'm sure that you guys, if you see it a second time, you're going to hear stuff and you're going to see stuff that you didn't quite sink in the first time that you're going to get the second time around. So I just really want to encourage you to do that, okay? At least once a week, you know, pick a lesson and just sit there and watch it all the way through. I'm telling you, you're going to gain so much information. You're going to hear stuff. You're like, yeah, I kind of remember him saying that, but I forgot all about it. And boom, it just sticks in your head. All right, so really, use these YouTube videos to your advantage. All right, we got a little bit more. Let's do this. Okay, yeah. Let's say we did this. I'm still purple. Let's make this white. Let's draw the other stuff in a different color. Let's move this right here. All right, watch what I'm going to do here. Now that's a nice little angle, isn't it? What I'm going to do here is I'm going to take another ray at the same vertex, okay? And I'm going to split this. I'm not just going to split it like this and make an angle. I'm not going to split it like this, but I'm going to split it. What does it look like I'm trying to do here? I'm trying to split it in half. I'm trying to split it into two equal angles. All right? So if I did that, now we can go to a color. Let's go red. Watch. Now, if I put one arc here and one arc right there, what does that say about this angle? We'll call it 1 and call it angle 2. They're equal to each other, okay? So if this angle has one arc and this angle has one arc, that means the two angles are equal to each other. Okay? Everybody good with this? We call this ray right here. This is a ray, isn't it? Tell you what, let's label this. We'll put angles. Sometimes I'm a little lazy, don't always put the arrows on the ends, but you can still figure it out. Let's go different letters this time. W, X, Y, and Z. All right. So angle 1 or angle what? W, X, Y, and angle 2 or what? Y, X, Z. They're equal to each other. So what is the ray that makes those two angles? What's the ray that makes those two angles equal to each other? XY, ray XY. We call that right there, we say that it divides it into two equal parts. We call that a bisector, okay? We're going to have several different types of bisectors, but this is a bisector. In fact, we call it an angle bisector. Write it down. So it's called an angle bisector. Now, what does that prefix bi mean? It means two, all right? So what do you think this ray does? It splits this big angle into what? Not just two angles, but two equal angles, okay? Two equal angles. So angle bisector, it splits it into two equal angles. Everybody see that? So when you see that word, that prefix bi in front of it, it means it makes two exactly the same angles. So it's an angle bisector. So if I had this picture and I said, what is the angle bisector? You would say what? Ray XY. And how do you do a ray? You do it like that. All right, so make sure you label things correctly. If I ask for a line, label as a line. If I ask for an angle, label as an angle. Ray, label as a ray. That's an angle bisector. Those two angles are equal to each other. Okay, so I could say this. Give myself a little room here. I could, since I put 1 and 2, that's always nice when they do that, I could just say angle 1 equals angle 2, couldn't I? Or, a lot of times the book will put this little symbol. Remember what this symbol is? No? If it was just a squiggle by itself, it would be approximately or about. But have we talked about this? I thought we talked about it. Okay, maybe we didn't. This symbol right here means congruent. I haven't mentioned that word yet?
No.
Must have been in my other class. I think it was in my honors class. Okay, so it means the same. It means the equal, but in geometry, a lot of times they use congruent instead of equal. To tell you the truth, I'm not real super picky on that. Some teachers really are. I'm not real picky. But if you look in the book, they'll probably say angle 1 is congruent to angle 2. All right? It's just another geometry word. It's a word that we'll use quite a bit. I'm not going to be real picky. I would be fine if you just said angle 1 equals angle 2. All right? But they say congruent. What's another way that we could name angle 1 and 2? Instead of calling it angle 1, I could call it angle what? WXY is congruent to or equal to what? Angle YXZ or ZXY. Doesn't matter. Okay, I really have no preference, but I'm going to write it YXZ. All right? So it means the same thing. So that means if it's an angle bisector, it doesn't just split the angle just into two parts. It splits it into what? Two equal or congruent parts. In geometry, a lot of times we'll say congruent. Okay, so into two congruent parts, two congruent angles. Everybody with me on that? That's a huge word. We're going to use that a lot, again, all year. We're going to use that stuff. Now, when I say that, I've said that several times, haven't I? When I say that, you should probably make a little note to yourself, okay? A little arrow, circle it, do something that when I say we're going to use it a lot this year, you know, write it down, circle it, underline it, do something so that you remember. All right, let's see what else we have here. Did angle bisector. Yeah, we talked about congruent angles. All right, let's do this last example and we'll be finished. And let's see, this looks like it's kind of going like this. This is on page 40 if you want to look at it. And this kind of looks like that. All right, so this is kind of what it looks like. Let's label it according to what the book says. That's M, that's K, J, and we got, what, N and L over here. L. All right, and the problem says, let me see the problem. All right, here's what they tell you. They tell you that KJ and KM are opposite rays. Let's take a look at it. And I didn't put the arrows on there. We'll just pretend the arrows are there, okay? So KM and KJ are opposite. So what does that mean about this thing right here? It's a what? Is it 90? It's a straight angle. Good. It's a straight angle. It's a straight line. Okay. If they're opposite rays, it means it's straight. So it's not like just slanting just a little bit. They figured they have to tell you. They don't want you to assume that it's a straight line. They figured, oh, I'll tell you they're opposite rays, and so I know that that's perfect straight line right there. Everybody good with that? Let's see what else they tell you. KN bisects. Let's do this in another color here. KN, ray KN. Where's KN? Right here. KN bisects angle JKL. Let's find JKL. JKL is this whole thing right here. That's JKL. But this ray, it bisects this angle. So what do you think might be true here? That these two angles right here are what? Are equal to each other. Okay, so or congruent, right. And so we'll put little arcs there to show that they're congruent. Is that all right? Now look what else they say. Angle JKN, they say it's 8x minus 13. Well, let's find JKN. JKN, that's this one right here, isn't it? So this angle right here is what? 8x minus 13. Cleo, you're keeping me awake by snoring. Wake up. He's actually snoring. Hey, wake up. There we go. All right, so look at this. NKL. If you write this stuff down and you're thinking about what's going on, you won't be sleeping. So watch. NKL. That's this angle right here, isn't it? What's that equal to? 6x plus 11. What are we trying to do? We're trying to find JKN. JKN is this one right here. Okay, we're trying to find this angle. That's what we're trying to do. Well, really, if you find this angle is going to be the same thing, isn't it? So what in the world are we going to have to do here? Find x. Very good. Okay, we got to find what x is. Because if I know what x is, then I can just plug it in for x, go 8 times x minus 13, and I got that angle, don't I? All right, the deal is I got to find what x is. Well, I got to find a relationship. Now, this is a very simple relationship, but sometimes they get a little bit more difficult to see. So I hope everybody's awake, paying attention, has their head up, because you're going to be so lost, And I'm not going to really have any pity on you. I'm not. If your head is down and you're not looking up at me, and I'm talking to several people, somebody tap, 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 tap right here. Come on. Get up. Get your head up. Get your head up. Get your head up. All right? All right, but I want your head up, though, okay? When your head is down on the desk, it's telling me you're completely disinterested and you've completely tuned out. So get your head up and pay attention, okay? So let's take a look at this. Look at these two angles right here. What's true about those two angles? They're congruent. They're equal to each other, aren't they? So what do you think I can do with what that angle is and what that angle is? Okay, put them together and then do what? What do you mean put them together? Well, when you say put them together, I want something better than that. I mean, you're on the right track. You do something to these, but this is what to this? What's the relationship? They're equal to each other, okay? They're congruent. They're equal to each other. So guess what I'm going to do with 6x plus 11? I'm going to do what? No, I'm not going to add it. What did we just say? You said what, Daniel? You said they're equal. So 6x plus 11 is what? Is equal to what? 8x minus 13. Do you see that? All right. And then you do the algebra. Exactly right. This is something we're going to be doing all year long. Okay? Remember I said that a couple times today. This is very, very important. We see a relationship. We said this angle and this angle are equal to each other. Well, this is the value. This is what this, how many degrees this angle is, except I don't know what x is. This is how many degrees this angle is. So that means they have to be the same. 6x plus 11 and 8x minus 13 have to be the same. So how do I show them being the same? I set them equal to each other. I don't add them up. They're equal to each other. Mike, were you going to say something? Or okay, I thought you were going to add something to that. No, that's fine. So now what do? We do some math, don't we? So let's do some math. Remember what we did at the beginning of the year? Why we did all that stuff? It's because of this thing right here. So I'm going to subtract a 6x from both sides. Now why didn't I subtract an 8x? Because then I would have had a negative, right? Yep, because this way it's going to be positive. The other way would be negative. I just kind of like it to be positive, okay? All right, thank you. So let's do this. Subtract a 6x from both sides. And then, look, let's get rid of the 11. Let's do it in the same step. How can I get rid of that 11? Minus 11. And then, actually, let's just keep the 11 there. Sorry about that. Let's do this. We got the x here. Let's get rid of the 13. So we add a 13. That's the best way to do it, right? And add a 13. All right, so that cancels. That cancels. What do we get here? 24 equals 2x, divide by 2, and x is 12. But that's not my answer, though, is it? They're not really asking you to solve for x. Now, sometimes they do. Sometimes one of the questions will be find x or solve for x. Sometimes. This problem, they don't say find x. What do they say to find? Angle JKN. Well, where's angle JKN? It's right here. So what do we do once we know what 12 is? Plug it in. Exactly right. So we're going to take that and plug it in for the x. So it's going to be 8 times what? 12, and then minus 13. It's 8 times 12. 96 minus 13, and that's what? 83. Yep. And so, how many degrees is that angle right there? 83 degrees. Put a degree symbol on there because that's the measure of it, and there you go. I tell you what, that's the kind of stuff that you're going to be doing all year long, I promise you. Now, there are going to be different pictures and all that kind of thing, but that's a big part of what you're going to be able to do. You got to take a look at the stuff that they give you and see a relationship. Listen now. And see a relationship. What is our relationship? And I'll say that phrase a lot, and I know it goes over people's heads when I say it sometimes. When I say find the relationship, what is in common with those angles? What's true about those two angles right there? They are what? They're the same. They're equal to each other. So if I know kind of what this angle is, and I kind of know what this angle is, what do I do to those two angles? I set them equal to each other, okay? I'm not adding them together, am I? I'm just setting them equal because they're exactly the same angles. How did I know they were the same angles? Because what did they say about KN? It was a what? It was an angle bisector. So if it bisected, this angle and this angle are exactly the same, so I set them equal to each other, did some algebra, and then I got what x is. But we're not done. You got to understand what you're trying to solve for. You're trying to solve for this angle, JKN, right? You stick it in there and it works. I could have also, if I wanted to, I could have put it in for this one, couldn't I? Would you agree? Because 6x plus 11 is the same as 8x minus 13. So I could have put it in this one too. Let's do that just for fun. Watch. 6 times, what? What did we say x was? 12. Plus 11. So 6 times 12 is 72. Plus 11 is 83. Look at that. We got the same answer, but we got it, plugging it into two different things. But they're not really different though, are they? They were the same because these two angles are exactly equal to each other. I'm telling you, if there's anything that you go back and look at, it would be this example. This example is very, very important for you to understand because we're going to be doing this kind of stuff over and over and over again in here. And some people have a hard time seeing it at first, but then one thing I like about teaching geometry is sometimes people struggle with it at first, but then they have that light bulb moment. You know what I mean by that light bulb moment? Like on cartoons, if they think of an idea or they get something, right, a light bulb pops up. Right? It's like the lights turn on, right? You're in the dark, and all of a sudden the lights turn on. Oh, now I see it, right? You get the idea of the light bulb moment? Sometimes people struggle, and then it seems like they do one problem, and then, or they hear one explanation, and then all of a sudden, bang, the lights come on, and they get it. And then from there on out, it's smooth sailing. Okay, I've seen that so many times, over and over and over again, all the years that I've taught geometry. Okay. So now I'm going to give you the right worksheet today, all right? So the right worksheet is section 1.4. I gave you the wrong one. Okay, so section 1.4 is what I'm going to give you today, all right? Okay, I already said this at the beginning of class. I said that if you already did 1.5, said hang on to it. Don't. You didn't do 1.4. Did you print it out from home or something or what? Because I didn't hand it out. Well, if you're printed out, if you've already done it, then you're done it. I don't know what else to say. Okay, if you've done it, you're done it. But if you haven't done it yet, I'm going to give it to you now. All right, and then you're going to do it tonight. All right.